Mm-hmm.
Okay.
Yeah.
Okay, welcome everyone to our August Green Infrastructure, Climate and Cities Seminar Series. Today we're going to have Mr. Dan Bader as our presenter to talk about some projects in New York City with CC-RON. Mr. Bader is a program manager at Columbia University's Center for Climate System Research. His primary responsibility is managing the Consortium for Climate Risk in the Urban Northeast, which is CC-RON, a NOAA research project. CC-RON is also the sponsor for this seminar series. And today he is going to talk about some research projects for CC-RON in New York City. So, Dan?
Thanks, and thanks everybody for joining this month's seminar. I'm coming remotely from New York, and I know that we have partners and participants from throughout the Northeast, so thanks for joining. These seminars are one of the greatest working pieces of CC-RON in many ways, and they're a great way for us to bring in scientists not only from our project team, but from experts outside of our team to keep the audience engaged and really cover some really interesting topics as we go through each month. Today, I'm actually going to be talking about some infrastructure-related work that we're doing in part with CC-RON and in part in some other projects that we've taken here at Columbia University. But given that I am the program manager of CC-RON, and it's my job, as Ziwan mentioned, to make sure the project is functioning on a day-to-day basis, what I wanted to start the talk off with today is just giving an overview of what CC-RON is, how the RESA program works, and how the research that we present and how the themes that we determine our seminars are based on come to be. So I think it's an opportunity for those who have been joining the seminars on a regular basis for a chance for you to understand.
Hi, Dan.
Yeah, you lost the audio, so. Not sure if you can hear us. Yeah, so here. Moving the next on. Yeah, we're just gonna give him a quote from this. All right, so who's in charge of the audio?
Me.
First, Brian. Huh, that's weird. I think it's not yours.
Hey.
One of 11 projects around the country. And we're unique in the sense that we are the only research team with a principal focus on urban settings. Many of the other researchers cover states. There'll be groups of states of which they cover. We're focused on the urban corridor running from Philadelphia through Boston. Our three hub cities being New York City, Philadelphia, and Boston, with smaller and medium-sized cities throughout the region that we are in fact engaging with. The map we've put together here shows kind of our rough geographic boundaries as defined by metropolitan area counties. So if it falls within one of the metropolitan areas of Philly, Boston, or New York City, it's marked on this map. That's how it's put together. That's roughly the area of where we are focused. We've previously defined things based on infrastructure sets, where the rail line's ending up, and we'll talk a bit about that in a bit. CC-RON's a partnership of many universities. This number's actually increased to 7 since the last time I made this slide. It needs to be updated, but Columbia University is a lead organization. We're partners here with Drexel, where the seminar series is hosted from. We have partners at Hunter College, City University of New York, Stevens Institute of Technology in Hoboken, We have UMass Amherst as partner, and our new partners are Cornell University in Ithaca and also Boston University. So we're a multi-institutional partnership, and what we really are funded to do is stakeholder-driven research. And what does that mean? Well, some of you on the line may in fact be our stakeholders. Our stakeholders are any essentially user of the information we're able to generate through our research. They could be city governments, municipal organizations, community groups, NGOs, private sector businesses. All of those groups are our stakeholders. They have an interest or they have a need in weather and climate assessment, weather climate information, and what we're funded to do is conduct research that will lead to outcomes and deliverable that will be beneficial to our stakeholders. In many cases, we're partnering with our stakeholders such that we can co-generate information, so we can develop the best materials, the best products for their needs, while providing the scientific expertise. And at the same time, we are encouraged, with the funding we do receive, it's kind of to get us thinking. We take the next step of partnering with our stakeholders to go out and seek further funding for future and additional research project opportunities. So that's a little bit about how the RESA program in itself works, a bit of an overview of who is participating in CC Run. When we look at the different research sectors and themes that CC Run focuses on, the three cross-cutting themes, we'll start with our three key sectors. We have three project sectors and three cross-cutting themes. The water droplet represents our water sector, which is led out of UMass and Amherst. We have the public health symbol for our public health research team, which is now led out of Boston University. And the shell represents our coastal research team, which is being led out of Stevens Institute of Technology. These three research sectors are the primary focus of our research activities. Now, what we have across of these three sectors are three primary cross-cutting themes. Climate risk information, that's being led out of Columbia University. We have the engineering and urban design, that's being led out of Drexel, and social dimensions of adaptation is being led out of CUNY at Hunter. What these cross-cutting themes are issues or topics, themes that are relevant to each of our sector. And the way our project is structured and what we really emphasize and try to do in our project is interacts very, very often and frequently amongst our team. Climate information, for example, is relevant to all three of our different research sectors, but it also has some crossover with the cross-cutting themes. And while we're not showing it here in this presentation, we have a whole schematic, a framework, a research template, how to get the teams interacting with each other. But across all of our work, these cross-cutting themes are really there to inform and guide the individual work of the research teams. Many projects and many of the stakeholders' interactions that we participate in, two of the teams, a sector and a theme, are paired together. We work very closely with each other and on a variety of projects throughout the Northeast. Jumping forward, now that you understand a little bit more about what CC Run actually, how it works, who's involved in the project, we'll talk a little bit about what do we actually provide. And there's a couple different types of information that we're providing. The first information that we provide and participate in is in the development of decision support tools. This one is focused on Jamaica Bay. We have another great decision support tool we've created for the Hudson River. Here our partners at Season and Stevens have partnered with the Wildlife Conservation Society. That's our stakeholder in this instance, to develop a flood mapping support tool for the Jamaica Bay region in southern Brooklyn and Queens here in New York City. What the tool allows you to do is overlay some of the climate scenarios, the climate projections the climate team for CC Run has worked on, and to understand how the bay may be impacted in the future, in addition to seeing how it's evolved over time as well. There's some historic information, and then there's also a way forward, and then it takes a look at how certain types of adaptation strategies for Jamaica Bay may be able to help prevent and protect areas along the coast under future climate scenarios. Our Hudson River Valley Flood Decision Support Tool works in a similar manner, showing vulnerable locations along the Hudson River Valley, and then for example, you can see where power plants are located related to the floodplain, and then it's showing the climate scenarios, the sea level rise projections as well. So I think in just this simple example of this one particular tool, you can see how our teams are working together, our data science team, which is another cross-cutting element of the project, working with our coastal sector leads and now a stakeholder who will take this information, and we've developed this tool, and now this tool will help inform planning and decision making throughout the Jamaica Bay region. That's the stakeholder impact, the stakeholder uptake, and then further dissemination of the information is quite important as well. In addition to decision support tools, we have developed climate risk information. Most notably, we have developed, our science research team has developed the climate projections of record for the city of New York. This is documented in in the work of the New York City Panel on Climate Change. Affiliates of CC-RUN are members of the NPCC, the New York City Panel on Climate Change, and most notably is that the technical research team of the NPCC, all the climate science projections that are generated for New York City have been worked on and developed by CC-RUN researchers. So on the cover of the report here, this is the 2015 NPCC report. Those are the sea level rise scenarios for New York City, the projections for future sea level rise. Those were developed by CC-RUN researchers at Columbia. In addition, we have provided climate information of similar manner, climate projections to the City of Philadelphia. City of Philadelphia is working with our sea level rise projections. We've done the same for Boston as well. And in individual cases, we've worked with some of the smaller cities in the region to either provide general or more broader assessment of climate risk, general projections, but also targeted responses as well. We're working, for example, through another grant, but closely linked to CC-RUN on coastal communities in Connecticut. And we've given them some extreme precipitation projection information and historical analysis, similar to kind of the main idea of providing climate risk information. And in the cities and across our different stakeholders, it's really this scientific information that is fundamental to any future planning process, any future resilience activity, any decision making. It's grounded in the science, the approach that we've always taken with our research. And what I mean by grounded in the science is that the projections here are local. They're the best available data, best available information available for planning, and having that local flavor, that local touch really guides the process better. We're not taking a number for the United States. We're not taking the number for the state. We're taking it as close as we can get for the science information to make sure that the decision making is best informed. We're planning for what we think the future climate scenarios may be in and around the urban Northeast. And that's been a fundamental process that CC-RUN has helped to push along and has received recognition for as well. There are some examples at the federal level of either federal mandates, executive orders, which have language that are very closely linked to kind of our mission in terms of the best available local data. So we are making a difference not only in the communities that we're serving in the Northeast, but through in the broader climate conversation across the nation as well. And many CC-RUN scientists have participated in the National Climate Assessment process and various reports that have come out through that. What we do at CC-RUN, and I think is really a fundamental trademark of our work, is that it's an integrated process. And here we're just highlighting some stakeholders that we work with since we are based in New York City. We've worked with here in New York City. This is not supposed to be New York centric at all. This talk is focused on the Northeast. These were just easy logos to pull because these are who, in fact, our group here at Columbia is really closely involved in working with. But what we've developed and crafted over the years with CC Run is this integrated process. And what I mean by that is we don't just run climate scenarios or find what we do is work back and forth with the users of our information. What that allows is for them to get the most specific information relative to their needs. So they may have a certain temperature threshold at which point their infrastructure will break down. We can tailor our projections so that we're giving, days over 85 degrees. If days over 85 degrees is the most important thing, we want to work and hear back and forth of what the science information is being used for. We kind of go back on that side and say, here are the uncertainties, because if you are planning for the future, the numbers aren't by any means perfect. You have to incorporate uncertainties, so that gets discussed in this integrated process, really allowing this co-generation of information such that the best available data is in fact available. And through this process of integration, what I think you've seen with time is that the stakeholders have gotten much more familiar with the data and with the information that we're working on. So the conversation has changed such that we're being asked sometimes in real time for certain pieces of climate information, or how does this relate to the projections that we've already developed. If a paper comes out showing the potential for really high-end sea level rise, does that in fact require us, the scientists, to change our projections, to update the numbers? Those questions are really an example of how the success of this process has worked in terms of going back and forth, such that we're generating the best available information. I think this is the final piece of information or example of what we're providing. We provide peer-reviewed literature. As most of our team is academic in nature, our results, our work is being published throughout a variety of journals. Our website and our annual reports have full lists of the different publications the team has worked on over the past few years. This paper is on climate change and the impact of extreme temperature on aviation. We'll talk about that slide towards the end of this presentation, as that's one example of how our climate science information from CC Run is in fact informing decision making, or can inform decision making in critical infrastructure sectors, in this case being the aviation industry. And just to sum up here, multiple CC Run products are informing decision making, not only in the New York City metropolitan region, but throughout the urban Northeast. Our annual report that we submit to NOAA every year and is available on NOAA's CPO Climate Program Office website documents different areas we're working in. So we've done a lot of work, for example, in Cambridge in Massachusetts. We've done work in Camden, New Jersey. These reports document the exact engagements that we've had at each of these local communities, and showing how decision making is being informed. At the New York City level, there are multiple initiatives for resiliency planning that require certain levels of protection against various sea level rise scenarios. Those would be the CC Run sea level rise scenarios, for example, there. So we are making a difference. Our work is known across the Northeast, and we really are serving a variety and a very diverse group of stakeholders to get them the information they're looking for. What is important to recognize and to understand about the approach that we've taken is that climate risk, climate vulnerability, it doesn't stop at geographic boundaries. So our process, kind of the products we just went through, all of that targeted research, it doesn't stop at the boundaries shown on, the county map. It doesn't stop at, where CC runs geographic borders end. It applies to a much broader region because of in large part because of the interdependencies between the critical infrastructure systems. So if the power network goes beyond the city, that feeds into the transit sector, you have to look at the full picture of what's outside just the geographical boundaries of where CCRN is located, but that broader region to really assess fully what the vulnerabilities are and then decide whether or not adaptation resilience strategies are something to be considered. So what I've shown here on this slide are New York City's water supply system, which is managed by New York City's Department of Environmental Protection, and the MTA, the Metropolitan Transportation Authority, which operates the Long Island Railroad, the Metro North Railroad, subway service in New York City and the surrounding 5 boroughs, and also a bus service in the city as well. So the MTA map shows that our train lines go way beyond where, let's say our climate projections are focused for. So the climate information that we've developed via CC Run is usually applicable for about a 100-mile land radius. So you can see that's important because the train line doesn't stop at the boundary of New York City. It continues out onto Long Island, or it continues into Westchester or Rockland County. If only those within a geographic boundary, let's say the 5 boroughs of New York City, are going to plan with climate scenarios, then the work isn't as effective because as soon as that train leaves the area, you're either running into an area that is under or completely not protected as well. So the climate information and this process that we work with, we try and engage as many people in the surrounding area as well. The same thing holds true with the water supply system. New York City's drinking water supply is coming from the Catskill Mountain area. So that requires, the science and the climate science information to be generated not just for New York City, but for upstate New York. And it can be different even over that small of a geographic area, not expecting too much of a difference, but the local information, local projections for the watershed then feed back into terms of the decision making that needs to be made in the city of water supply related questions. So we are going beyond the boroughs. We're not just focused on New York City specifically, but the broader Northeast in general. And in the big cities, in the big urban areas, we go outside to where these watersheds go, the infrastructure sheds go, to make sure that a full system is protected or has the information scientifically to be protected against, versus stopping at a geographic border, whereas the system borders go beyond that. So, and it's important to note that we're not just, while we are urban focused, we aren't only focused on the big cities. As I mentioned, we're working at the state level, so we've done work with the state of New York, for example. Local activities in the Philadelphia region, we've worked with the Delaware Valley Regional Planning Commission. So we are working at the smaller scale. What we do generally is we take that same approach to co-generation of knowledge, co-generation of the science, and now we apply it to smaller cities where it kind of fits right in. It fits very nicely because we're always hearing from the stakeholders, the users, the information, and a lot of the information and materials that we've prepared for the big cities can be customized to the smaller scale. We advance, our participation to the neighborhood and community level via engagement with the seminar series here. I know we connect based on the list that I know the seminar series goes out to, and also participants that we've had at these meetings in the past. We're covering a diverse group of neighborhoods across the Northeast, And we also partner with the Science and Resiliency Institute at Jamaica Bay on a series that does not meet as regular as the seminar series, which meets once a month. This is kind of a quarterly meeting to, maybe between 3 and 4 times a year, of which we hold these climate forums in the evening. Scientists speak, we have a key stakeholders speak, and then we have members of the community talk as well. And interacting with the members of the community is always valuable, and you always are amazed by the amount of local knowledge, the local expertise as far as the impacts. Everybody knows where in their neighborhood, it seems, knows where they know where they flood, they know what their past storm experience has been like. And as scientists, it's really valuable to hear those stories and to gather that information as a way of making sure that the resiliency efforts are being planned and targeted accordingly, and also kind of truthing the science in the sense that are the changes that are being observed lining up with the projections that we'd expect. Our first period of climate projections that we have for any science documents that we produce is the 2020s, which is the time period from 2010 to 2039. So we're already nearly 10 years into that period and can start saying, well, how is what's being observed actually lining up with what we are, in fact, what we projected. So the observations now are into the time period of the first set of projections. How are they, comparing? What pace or what track are we on? The final piece of our local activities is working at the neighborhood scale on targeted research projects. This is a map for some flood modeling we did with the DVRPC on rainfall flooding towards the Eastwick neighborhood of Philadelphia. So really fine scale, really high resolution modeling and assessments that we're doing there. Just to summarize, a couple examples of how decision making in the Northeast has been influenced by CC Run. The difference we're making, that we are in fact delivering products to stakeholders that they can use. Green and gray infrastructure investments to address extreme rainfall in New York City, primarily through New York City DEP, Department of Environmental Protection. A lot of the work that our engineering and urban design group, which is based at Drexel, is working on is helping to inform DEP on where they're choosing to build these natural, in many cases natural, buffers that can help build resilience, reduce coastal storms. New York City has a set of climate resiliency guidelines that ensure buildings and infrastructure are designed to withstand hazards in a changing climate. Those guidelines are based, in fact, on the work of the MPCC, the Climate Projections of Record for New York City. And a final example here is the work that we've done with the telecommunications sectors to harden their network, strengthen the city's support of mission critical functions. A lot of materials here in New York City, some of the infrastructure is above ground, it's not buried, so you can have damage in storms for cable and other telecommunications infrastructure. When there's a windstorm, if there's an ice storm, so just placing it underground is one adaptation that's possible. However, it's not an end-all be-all, because you could have flooding of equipment beneath a certain level of the surface, so you would have that issue to deal with, and you would also potentially run into additional problems. It's very costly. Let's say if we wanted to bury additional infrastructure and between that and the flooding aspect, it presents challenges. And on the right hand side of the slide are additional examples of flood and other climate risk protection that has been taking place at the city level. This is from the city's 1YC part report. So you can access that report online, free to download to see more of the work. And all this work is being based upon NPCC, and therefore CC Run climate projection information. So that just kind of covers what CC Run does. Hopefully it's been informative. Now you know a little bit more about the project, a couple examples of kind of broadly how our team is structured, who we are, how we're working together, what we're trying to deliver to our stakeholders, and how our stakeholders are using that information. What I'm going to go through now, and the next set of slides is actually a specific example of targeted research related to infrastructure that our team here at Columbia is working on as part of CC Run. This will be covering the climate change vulnerability study. This is a partnership between the Con Ed in New York City, Columbia University, and there's also a private sector consulting partner on the project as well. So what we will do is start off just talking a little bit about Con Ed for those who are not familiar with the company. Con Ed, this is a portion of the larger company. This is the utility that provides electricity, gas, and steam to New York City. So all 5 of the boroughs and surrounding areas. They manage assets and infrastructure in Westchester County as well. There are 3.4 million electric customers, 1.1 million gas customers, and 1,600 steam customers. Electric, gas, and steam are the main services that they are providing. That's what this study is focused on, looking at those 3 particular categories of infrastructure and equipment. The distribution system of Con Ed, it's over 37,000 miles of overhead lines, close to 100,000 miles of underground lines, so a tremendous amount of wired network. Overhead lines vulnerable to wind and other extreme weather impacts, underground vulnerable to flooding. There are 39 substations for transmission and 62 area general stations, over 14,000 employees, and the company is very large, $13 billion in revenue in 2016 and $47 billion in assets at that time. Large company, a key stakeholder is doing some great science research, which we'll talk in a bit about what we're actually working on for them. But why does climate risk, and why does Con Ed look to come to talk to CC Run about these issues? And the rationale for that is that weather and climate matter for Con Ed. And this is just one utility. We'll walk through another in a bit. But you could think, if you're a utility manager or you work in a city agency, of how climate risk really can make a difference, and it might not always be known to you if you haven't specifically been tasked with or charged to think about it. We talk about high temperatures. High temperature and humidity, they stress workers and equipment. You know, there's certain temperature thresholds of after which, if they're exceeded, work outside becomes very uncomfortable, for example. So we provide projections. We can talk about projections of heat and humidity. Coastal and inland flooding threaten critical infrastructure. During Hurricane Sandy, nearly 1 million Con Ed customers lost electric power. 5 times the previous record, which was only a year prior, Irene. The picture here, the graphic shows most of Manhattan without power following Sandy. The generating station at 14th Street in the East River took on water and shut down, preventing the city. Basically anywhere south of 34th Street did not have power in the days after the storm. The one area that did, and you can faintly see it on the far right side of the image, in the back of the image, is Battery Park City, which actually has separate grid for their electricity, which was raised in the event and preparing for the possibility of future flood risks. So an example of adaptation and resilience from many years ago in the construction of Battery Park City, which allowed that to be the one area that did not lose power across much of Manhattan, south of 34th Street. So there's definitely interest in weather and climate risk information for the the energy sector and for Con Ed. Following Sandy, Con Ed sought to raise their rates to help pay for future resilience effort focused on climate resilience efforts. The Public Service Commission authorized a climate change vulnerability study, which members of CC Run are now working on. The way our project works is that we have approximately 40 experts at the utility itself. So working at Con Ed, we have teams of experts, broken down by electric, if they're working electric, if they work in steam, if they work in gas. So we have all those 40 partners. We have we have a private consultant that's leading the report writing and the broader risk assessment. CC Run climate scientists were providing downscale projections tailored to the utility needs. What this project has really pushed us as scientists and kind of advanced our knowledge is working on climate variables or pieces of climate information that are sector or project specific. We're calculating, for example, this temperature variable, which is a metric that's specific to the utility itself. It's not something you would see reported in a forecast or anything like that. It's a calculated number that makes a difference to the operation of Con Ed, and that's what we want to provide them with. There's also an advisory committee that draws in many stakeholders from the city government, for example, that guides the project through regular meetings. Stakeholder group, the advisory groups include stakeholders from the broader region and local governments, as I had mentioned, to guide the project as it in fact goes along. For the study, there's a set of deliverables that we're going to be producing. This really focuses on the climate science deliverables, not anything like the report writing or anything of that nature. We've started and we're kind of moving through chapter 2 and 3 as we speak now. We've provided projections and historical observations for temperature, also for humidity, as I mentioned, for that temperature variable marked here as TV. We calculated a number of degree day metrics, which are slightly different than National Weather Service definition of degree days. And there have also been applications where they've taken our data, or the consultants taken our data and fed it into a sector-specific application model, an every sector demand model, or something of that nature, for example. Precipitation, we're now starting our work there. Anything marked in blue here, those would be where we provide qualitative projections for. The science just isn't there for these particular variables to offer quantitative a number of how many times or how percentage-wise more often a certain event can go. We don't know, let's say for ice storms or hailstorms, we don't know that for lightning or hurricanes. We have the general trends that are available predominantly from the National Climate Assessment that show the broader trends of these variables over time. But it's not the focus here of giving quantitative numbers. Will provide qualitative information as best available. So what this project is really teaching us, and it's a fantastic endeavor that we've been able to work on, is that it's an excellent opportunity to advance both the climate science and the decision science. It's really challenged us in working with some of these climate variables that we do not typically work with or provide projections for. It's made us get out our textbooks, let's say, and go back to some numbers and equations to make sure we're calculating and working on things related, in particular, to heat and health. Con Ed is an example of a very highly motivated stakeholder. They're concerned, they want to take a risk-based approach. Part of that process, that co-generating process that I mentioned before, it's a risk-based approach. Decisions are being guided based on individual, either user or agency user tolerances, risk and using risk to identify what thresholds of protection should be taken. It's a bit challenging, coordinating in different groups, 3 different groups of people all working at different time things and on tons of different work, but it's a good learning experience for us, and I think that's something that we really take forward through all of our engagements with stakeholders across the Northeast is that we really do have the opportunity to push and advance the science and get deliverable information despite any logistical hurdles that do pop up. We're hoping thinking about ways we can engage and promote our work into the broader areas is something that we really are in fact concerned with and thinking of doing more and more frequently. So the Con Ed study looks to wrap up about a year from now, next August, in August 2019, at which point I think the summary report will be available. Very interesting work, really challenging us from the science side. Our science team at CC Run is really the lead participant from our team in the project and is really, really advancing how we're working with climate projections and understanding the large impact that our numbers, our science really does have, given how large and how valuable Con Ed or any other electricity utility in the region is. And it's not just electric, it's transportation and other sectors as well. We'll actually jump ahead to the next slide here, which talks about the different a different project that we're working on, more transportation focused, more transportation infrastructure focused than the energy sector work that we're doing for Con Ed, but we're working with the Port Authority of New York and New Jersey. Some of the CC Run scientists are participating in a working group on climate change impacts. And what the working group really highlights is another way for CC Run scientists to engage with the users of their information, for us to engage with our stakeholder partners. And the working group, there's a number of members of CC Run who are on the working group. We'll talk about that a bit. Just to give a brief overview for those who aren't familiar with Port Authority of New York, New Jersey, it manages the infrastructure critical to the region's trade and transportation. What does that mean? If you've ever flown through Kennedy, Newark, or LaGuardia Airport, those are all managed by LaGuardia. They're not managed by LaGuardia. They're all managed by the Port Authority. They're responsible for the marine terminals and the ports, a large port of New York and New Jersey, and coastal New Jersey, just across New York Harbor. They manage the path rail system, and the path rail system runs from Manhattan into New Jersey, another train service available. The Port Authority manages a total of 6 bridges and tunnels that connect New York and New Jersey. So if you've traveled via car between the two states, you've likely crossed a Port Authority facility there. Manage the bus terminal, Port Authority bus terminal at just west of Times Square in Manhattan, and they also manage the World Trade Center site as well, the buildings in that area. So a large entity that is greatly concerned about climate and climate risk. Why do weather and climate matter? Again, this is the same slide that we looked at before with Con Ed, with some different impacts shown here. Higher temperatures, they can damage road and railway, so tunnels, bridges could be at risk of material breakdown from high heat waves in the summer, so that's one threat the agency faces. They also face coastal and inland flooding that could threaten critical infrastructures, a tunnel filling with water, for example. Flooding at airports is another example, or if their power generation is in the floodplain that feeds these pieces of infrastructure. Following Hurricane Sandy, LaGuardia Airport, which is shown in the picture here, the airport remained closed for about 4 days after the storm. You could see the runway was flooded with water. Flooding of infrastructure, can make these sites inaccessible. Great impact, tremendous economic impact here as well. Think of how many flights are canceled, closing an airport for 4 days. Think about the backlog that such a situation creates. The economic losses is very, very great. For example, with the ports, there was so much debris and the water following Hurricane Sandy that the ports had to be closed. They couldn't move marine traffic safely. That prevented the flow of fuel into areas, for example. So you could see the interconnectivities, and that's one of the things, as I had mentioned previously, that we're trying to highlight with CC Run is in this urban environment, the interconnectivities between critical infrastructure systems. One impact is not always isolated. It's not that a power station floods. If the power station floods, the transit system stops, and when the transit system stops, you have great economic loss as well. So interconnectivity, but the Port Authority is very, very, very concerned about their infrastructure, their operating capacity in a future climate with climate change. So they've put together this work group that has met over the past 6 months or so is when it's taken off. The CC Run climate science and coastal science, coastal zone teams members are participating. So folks from here at Columbia and also at Stevens are on the working group. Some of our stakeholder partners are also represented on the working group. So it's good. It's a good way to connect with them and see what our stakeholders and other academics in the area are working on, look for partnerships through them. The working group is focused on identifying the impacts on the region's critical infrastructure and operations in the future. The goals being enable the agency and its regional partners to more fully consider the current and future impacts of climate change, and also to prepare the agency for the impacts that they may cause in the future. They're looking to be able to operate with as little impact as future under changed climate scenarios as they go in the future. The culmination of this working group participation will be a report that is scheduled to be released sometime over the next couple months, documenting the work. All the work that the Port Authority was putting together as part of this working group was using climate scenarios, climate data that CC Run prepared. What we're also looking to do with the Port Authority is work on some decision support tools. And they're an example of where it's not a one-size-fits-all approach when we develop climate projections and climate risk information. Some of the metrics, we typically use days over 90 as one heat statistic. It's recognized in the meteorological community by National Weather Services as a decision point. We've been told, let's say, by Port Authority that they want other metrics, so we can either tailor it specifically or work with them to provide the data such that they have the best available information that for their specific needs. So it's another example of another part of the critical infrastructure within the region that faces vulnerabilities from climate and how the agency is responding. There actually are operations underway, and it's not just Con Ed and it's not just the Port Authority. It's all, so many different examples can be provided throughout the CC Run region. But our information, our science is being used, and planning efforts are undertaken to prepare for the future and climate impacts as they may come. The final piece of work that I want to go through in this presentation and is infrastructure themed is climate impacts on aviation. And this work was led by Ethan Koffel, who was a graduate student of CC Run's lead PI, Bradley Horton. And what they did is investigate the potential impacts that climate may have on the aviation industry. What happens is when you have rising temperatures, both mean and extreme, it will impact the air transit system in the coming decades. And the reason why is if you keep pressure constant, you increase temperature, air density declines. And when you have a less dense environment, warmer environment, it's less dense, you don't have as much lift generated by an aircraft wing, so a plane trying to take off. Since you don't have as much lift, you cannot lift as much. Therefore, it imposes a weight restriction on a departing aircraft. We actually, there were some heat wave in Phoenix, I think it may have been within the past 3 years, where we actually saw some of these impacts that we're going to go through being discussed, that there is a impact in aircraft operations at the airport because the temperatures were in fact so extreme. What the study here did was they took a general model to project future weight restrictions across different aircraft, looking at different takeoff weights and looking at a variety of different airports. Weight restrictions depend on not only the type of airplane you're flying, whether it be a 737 or a 787, so the difference between a narrow body and a wide body aircraft, but also different areas. The airport here at LaGuardia has different requirements than the airport at Denver because they're a mile high. The air environment is different there. So what this study took is a comprehensive look at the different impacts that rising temperatures may have across the aviation industry. They looked at 5 different commercial aircraft, 19 airports around the world. The temperatures came from the CMET 5 model suite, looking at 2 emission scenarios. So a very comprehensive study scientifically to really assess the full impact potentially of higher temperatures on the aviation industry. What their study found is that on average there's a 10 to 30% of annual flights departing at the hottest point of the day may require weight restriction below their maximum takeoff weight. Mean restrictions range from about 0.5% to 4% of total aircraft payload and fuel capacity. That's the constraint by mid to late century. So you can see that aircraft operations could be significantly impacted with a warmer environment. Those are, think about 10 to 30% of annual flights may not be able to operate at their full capacity. That means they're not able to transport as many customers. And think of that in a dollar and cents context. It's both going to impact mid-sized and large aircraft. So the study had similar findings for different types. Generate more lift, so shortened runways don't have the ability to compensate for warming temperatures by sending the plane a greater distance by takeoff. Same situation for those at high elevations, that is still going to put the challenge even more so under a warmer environment. The study suggests that weight restriction may impose a non-trivial cost in airlines, and that operations around the world may be impacted, and adaptation strategies may be required, looking at aircraft design, schedules, and or runway length. Operations could greatly be impacted. There may become periods where we're not able to send airplanes for takeoff because it's just too hot and not functional at that time. So you could see flights earlier or later in the day, for example. Changing runway lengths, while it sounds like an easy fix, obviously there's constraints on the space. We can't build the runways here in New York City any longer. We're constrained to the boundaries of the airports as they are now. So just another example here in the study of the wide-ranging impacts that climate change and climate already has on infrastructure. And thinking about air traffic across the United States, it's greatly concentrated in the Northeast with so many major international airports up and down the coast here. So this work, while it wasn't done in particular for a single stakeholder, you can in fact see how it may be very much relevant to the Port Authority as they're managing 5 areas here in the New York City area. And in fact, and on the working group for the Port Authority, this paper was brought up independently of us presenting it. So it gives you an example of how the stakeholders are using our work when it hasn't always been developed specifically for them. Seeing that is of interest obviously allows for the opportunities to expand the work and continue it a bit further in the future. I believe that is my last slide in my presentation. Just to wrap up, I think we went through a comprehensive, a pretty detailed look at what CC Run is, how the RESA program works, and how CC Run is working to deliver stakeholder-driven research in the urban Northeast. Hopefully that was informative. Realizing, as I was putting this talk together and these seminars, this is now it's really the third set of seminars that we've put together. There was the initial, and then the first, which continued the initial and the first phase of CC Run. Then phase 2 kicked off of the project. We had that seminar series, which has led into this and is continuing, and will continue with the new schedule coming in the fall. Thinking back on it, I realized that not many people actually have probably heard a bit about the program itself, so I thought it would be valuable to just share that here and then give these specific infrastructure related examples of some of the work that we are doing, how it is informing decision making. A piece that's not shown on the slide here is the evaluation component. All of our work at CC Run has a social science component. We're trying to evaluate, trying to measure the impact our work is making, and the measurable statistics are we can say 50 people. I don't know how many people actually. I can't see the attendance count actually, but measuring our impact is that 45-50 people attend each of these a month, so we can quantify it that way. We can quantify economic decisions that have been made, so we're trying to capture that more and more frequently as the work continues in the project, which still has some time left on it. Has 2 years to go actually in phase 2. Trying to measure that impact is another important piece that's not shown here on the slides. But hopefully these stakeholders examples have been interesting. Don't always think sometimes about how climate impacts, may affect our day-to-day lives. People fly regularly with no knowledge of how flying may become more difficult in the future due to warmer temperatures, for example. Everybody likes to complain when there's a power outage, not realizing that power outage may become more frequently if that utility does not start to think about hardening their infrastructure. We all travel across different pieces of roads, rails, marine transport. Again, another example of where we are vulnerable. And at CC Run, what we're really trying to do is work with the users of this information, the agency level folks who have an interest, and then therefore we try to deliver them the most comprehensive, the most local data and information that they can have, so they can plan and make decisions accordingly. So with that, I'll thank everybody again for joining us on the seminar today. Hope you enjoyed the presentation. Now I'd be happy to take any questions that anybody had for anything I've discussed or more broadly about CC Run in general, and any comments or discussion that wants to take place as well would be welcome. So thanks everybody.
Do we have any questions?
I'd be curious to know what the interaction is with the health sector.
Sure. So our public health work has really been focused, that's led by Pat Kinney at Boston University. What we have done with the health work is looked at a lot of heat related research, so increases or potential increases in heat mortality under different climate scenarios. We've done projections for all 3 of our hub cities. There's a paper available probably on our website actually that shows we've done the modeling for those 3 cities. We're looking at air quality, So looking at air quality monitoring and how that might impact public health. And another example of our public health work is there is a social vulnerability index for New York City. They did for the state of New York as well, but in the city, the social vulnerability, it's a vulnerability index. I may be misspeaking. I apologize if it's not a social vulnerability. It's a vulnerability index that was generated for the city that incorporated heat health risk, and that vulnerability study is underlying some of the adaptation and resilient activities that are taking place. Identifying the most vulnerable neighborhoods, then you can have a targeted response to make sure that those neighborhoods are protected, let's say when there is a heat event underway. So that's a sample of it. There is some information on our website, and our annual reports through NOAA's website also document the health work. We've worked in different areas across the Northeast. There's a lot of health work now being taken up in Boston as well.
Thanks.
I have one question. You talked a lot about stakeholders and regional or local work. So if we, for instance, are developing a local decision-making tool, is there a platform through CC Run for distributing that to potentially interested parties? Or is that not really your goal?
What we're trying to do is, if the tools that we've worked on and developed previously have been made available. I believe they're publicly accessible. So if you're in, let's say, the Hudson Valley, you can go to the tool. It's available just via website. I think any future tools that we're looking to develop would be designed in a similar manner. One thing that should be online pretty shortly is just be kind of a weather data portal that we're working on, so that you can come in, and it will be for most of the cities in the Northeast, where you would come in and you'd see, let's say the average temperature in the summer has been 85 degrees. What it would tell you is kind of how that relates to years past. Same thing for precipitation, and keep a tally of days over 90. So you can see in a dashboard format this weather information, and then also look at the trend of how the days over 90 have been changing with time. For example, that's another that will be on our website. We have plans to bring over some mapping tools from other projects that we've worked on into our website, but I believe the approach would be to make sure as much of the information is available to the public as possible.
Thanks. And then sort of a scientific question. You mentioned in the last part of the talk that it's the basis of your lift declining on the airplanes is that pressure remains constant. Can you just talk about the robustness of that assumption?
I wasn't actually involved. I would have to refer you to the scientists, to be honest, who worked on that assessment. I think the assumption is that in just kind of the basic physical relationship is that if you're not changing pressure, if you increase temperature, your air density is going to decrease. And I think the assumption, let's say from a science modeling standpoint, is that it's very uncertain how atmospheric pressure may change in the future. So that could be part of the assumption, but I could follow up with the researchers directly.
Thanks. Yeah, if it's true, it seems like Boeing would be a really good stakeholder.
Yeah.
Well, in a lot of countries that are very hot, those flights from the big airliners take off at 1 a.m.
Yep, that came up at the meeting recently with Port Authority that and I believe it in the Middle East that they fly overnight. And now the feasibility, let's say, of changing, just to show you the scope or the level of detail of here we have a problem that it's going to be harder to take off. Let's say in the afternoon on really hot days in the future. So we can just change the time when we're changing airport operations. Let's say we'll fly overnight more. But then you have the residents that live in the communities next to the airport who are going to be up in arms because it's bad enough that they have to listen to the incoming or departing flights on a normal day. Now it's going to be overnight when they're trying to sleep. It's not so easy. It's not such.
Not so simple. What's that?
Social problem too. that
Yeah.
You'll be arriving places at odd times,
Yeah, yeah,
partial
yeah.
time, which actually is part of the reason why a lot of flights in the East take off at ridiculous times, because where they end up going,
Mhm.
they arrive in the morning.
Do you have any other questions or anything? I don't think I can see from the chat if anybody's had any questions.
Well, there's no question online.
No question online.
But actually, Dan, I have a question on this. Do we, does CC Run has any open data that could be shared online so other people who interested can get these information?
We're working on doing that. I think what we're trying to do is, in particular, all of the climate projection data, the summary tables, let's say, that's always been available, and we can place that online. I think we've been asked more recently about the underlying data, kind of either observation data or the future climate, the individual scenario or for the individual models. We've been talking about it to make it more accessible and ways to do that.
I have a question. Have you, or has there been any coordination, correlation, connection between your data set and maybe what's being done from the insurance perspective, or valuation of property by looking at changing risk profile or premiums as a result of same? I mean,
I'm not familiar with any specific or documented connection. I know that our sea level rise data has been placed upon existing flood boundaries or flood zones to see how the flood zone may in fact change in the future, but I'm not sure how that's if it's been translated directly into changes in insurance. Following Sandy in New York City, there was a need to re-examine the FEMA flood maps, and CC Run, with our projections and kind of are working in and helping with some of the resilience effort, we came across that, but I don't know of any specific examples of that translate directly of how we changed insurance or influenced insurance. I mean, one thing you could think about is from the flood maps that we provided, let's see, in the New York City Panel on Climate Change report, it says, what the increase in population potentially could be if, sea level rises reaches a certain threshold by mid-century, how many more people would be exposed, but beyond that, I'm not familiar with anything.
Okay. Well, thank you everybody for attending this seminar, and we're gonna see you hopefully in next month, first Wednesday at 4 o'clock in this room. Thank you, Dan.
Thanks, everyone.
So it's